All right, today we are diving into a really cool new paper that totally flips the script on how we train AI. We're talking about a technique that turns an AI into not just a problem solver, but into a master teacher. Let's get into it and see how giving an AI the answer first might just be the secret to unlocking its real power.
So just let this question sink in for a second. It sounds completely backwards, doesn't it? I mean, it goes against pretty much everything we've ever learned about, well, learning. But this one counterintuitive idea is actually at the heart of a huge breakthrough.
Okay, so to really get why this new approach is such a big deal, we first have to understand the normal way we teach AI models how to reason. It's a process that's worked for a while, but it comes with a really fundamental and really tough challenge.
So the traditional method is called reinforcement learning. And it's pretty simple, really. You give the AI a problem, it tries to cook up a solution, and then you give it a reward, like a digital pat on the back if it got the right answer. It's just this constant cycle of trial and error, where the AI slowly, hopefully, figures out what works.
But what's the catch with all that trial and error? Well, when the problems start getting really complex, the error part of that whole thing just blows up into this massive obstacle. It's called the exploration problem.
And the paper defines it perfectly. It's the AI's struggle to find a correct answer just by chance. Think about it. If you ask an AI a graduate-level physics question, the number of wrong answers it could give is practically infinite. The odds of it just stumbling upon the right chain of thought by pure guesswork are, well, they're not good.
And I love this analogy because it just makes it so clear. Imagine you're dropped into a gigantic, complicated maze, and someone just says, "Find the exit." If your only strategy is to just walk around randomly, you are going to spend almost all of your time bumping into walls. It's super inefficient, and honestly, you might never find your way out. That right there is the exploration challenge.
So instead of making the AI student just wander around bumping into walls, the researchers asked a much better question. What if we first train an expert to just draw the map for the student?
And that map maker is exactly what the authors of this paper call a reinforcement learned teacher, or an RLT for short. The entire goal here is to have this RLT just hand the map to the student, letting it skip that whole inefficient, frustrating exploration part completely. So this is the fundamental shift. This is the whole ballgame. The old goal was to build a problem solver from the ground up. The new goal is totally different. Build a master teacher who already knows the answer and can create the perfect lesson plan to explain it.
Okay, this is where it gets really clever. How exactly do you train an AI to be a great teacher? Let's break down how this whole thing actually works.
So a reinforcement learned teacher, it isn't trying to find the answer. Its job is completely different. It's handed both the question and the final solution, and its only task is to connect the dots, to generate the clearest, most helpful explanation it possibly can.
The whole process is right here, but the real magic is in that feedback loop, in steps 3 and 4. So the teacher AI makes an explanation, and that gets fed to a student AI. But here's the kicker. The teacher model gets rewarded based on how well its student does. This system forces the teacher to get better and better at explaining things, because a better explanation means a smarter student, which means a bigger reward for the teacher. It's brilliant.
Now, this all sounds great in theory, but does it actually work? Does building an AI teacher lead to better AI students? Well, let's just get right to the data, because the results are pretty amazing.
First, let's talk about the size of the teacher model. It's just 7 billion parameters. You can think of parameters as all the little knobs an AI can tune to learn. And in a world of AIs with hundreds of billions of parameters, 7 billion is actually kind of small. It's efficient. Just keep that number in your head. And here are the results. This chart is showing us performance on some seriously hard graduate-level tasks. You see that tall bar on the left? Those are the students that were taught using this new RLT method. They didn't just do a little better, they completely blew the other methods out of the water. It wasn't even close.
And this, to me, is the craziest part. Remember that little 7 billion parameter teacher? It created students that were smarter than those taught by methods that use AI models hundreds of times bigger. That is just incredible. It's like a tiny, efficient teacher outperforming a massive, sprawling university. It's a huge win for efficiency.
So let's just recap the big wins here. You get higher performance from your student models, period. You get there way more efficiently. This method even works great for teaching bigger, more powerful student AIs. And maybe the most impressive thing of all, the teacher can work zero shot.
That means it gets so good at the basic skill of explaining things, it can create great lesson plans for totally new problems it's never seen before.
So what does this all add up to? What's the big picture here? Why does creating a better AI teacher really matter for the future?
The real takeaway here is that we're moving from a bigger is better mindset to a smarter is better one. Instead of forcing every new AI to basically reinvent the wheel, we can create one expert wheelmaker, a small reusable teacher model. This expert can then go on to efficiently teach an entire generation of AIs, saving just an incredible amount of time, energy, and money.
And this leaves us with a really fascinating final thought to chew on. This research proves we can train an AI to be a genuinely exceptional teacher, one that can explain really complex stuff with amazing clarity. So it kind of begs the question, right? Once we perfect the AI teacher, who will it teach next? Another AI? Or maybe us?